Imagine pressing the power button on your computer. One machine is ready to use in less than 10 seconds. The other takes nearly a minute. Both have similar processors. Both have the same amount of memory. So what's causing the huge difference? The answer is hidden inside a small component that most people never think about. And once you understand how it works, you'll never look at computer storage the same way again. Today, we're uncovering why SSDs are dramatically faster than HDDs, how they actually work, and whether upgrading is worth your money. Let's begin. Almost everyone has experienced it. You click an application. Nothing happens. You wait. The loading icon spins. You wait some more. Maybe you're opening a game. Maybe you're editing a video. Maybe you're simply starting Windows. Many people blame the processor. Others think they need more RAM. But surprisingly, storage is often the biggest bottleneck. Think of your computer as a restaurant. The CPU is the chef. RAM is the kitchen counter. Storage is the warehouse where all ingredients are stored. It doesn't matter how fast the chef is if ingredients take forever to arrive. That's exactly what happens when your storage device can't keep up. And this is where SSDs and HDDs are completely different. How HDDs actually work. To understand the speed difference, we first need to look inside a traditional hard drive. An HDD, or hard disk drive, stores data on spinning magnetic disks called platters. These platters rotate thousands of times every minute. A tiny mechanical arm hovers above them. Whenever your computer needs data, this arm physically moves to the correct location on the spinning disk. Imagine looking for a specific page in a giant encyclopedia. You must first find the right volume, then turn to the correct page, then locate the information. That process takes time. Now imagine doing that thousands of times every second. That's essentially how a hard drive operates. The biggest limitation is simple. Everything is mechanical. The disk must spin. The arm must move. The data must pass underneath the read head. Even though this happens incredibly fast, physical movement can only be so quick. And that's why HDDs eventually hit a performance ceiling. Now let's compare that to an SSD. SSD stands for solid-state drive. Unlike HDDs, SSDs have no spinning disks, no moving arms, no mechanical parts at all. Instead, SSDs store information inside flash memory chips. Think of it like a massive digital library where every book can be accessed instantly. There is no searching, no waiting for a disk to spin, no mechanical movement. The storage controller simply requests data and receives it almost immediately. This tiny difference completely changes performance. Files open faster. Programs launch faster. Games load faster. Operating systems boot faster. And the computer feels dramatically more responsive. Not because the processor became faster, but because the data arrives much quicker. Let's put this into perspective. A typical hard drive might read data at around 100 to 160 megabytes per second. A standard SATA SSD can easily reach around 500 megabytes per second. That's already several times faster. But modern NVMe SSDs take things even further. Many can exceed 3,000, 5,000, or even 7,000 megabytes per second. Think about downloading a huge video project. An HDD may take minutes to transfer it. A modern SSD can do the same job in seconds. The difference isn't subtle. It's immediately noticeable. Even people who know nothing about computers can feel the improvement. If you're a gamer, storage speed matters more than you might think. Modern games contain enormous worlds filled with textures, models, sounds, animations, and effects. The game constantly loads this data while you're playing. With a slower HDD, the system can struggle to keep up. Long loading screens become common. Textures may appear late. Some games can even experience stuttering. SSDs reduce these issues by delivering data much faster. That's why many modern games recommend or even require SSDs. As game worlds become larger and more detailed, storage speed becomes increasingly important. For video editors, photographers, and content creators, SSDs are often game-changing. Editing high-resolution footage means constantly reading and writing massive files. Every second saved adds up. Preview generation becomes faster. Project loading becomes faster. Rendering workflows become smoother. Instead of waiting for your computer, you spend more time creating. And for professionals, time is money. Are SSDs perfect? Not exactly. SSDs have many advantages, but they aren't perfect. The biggest downside is cost. Although SSD prices have dropped dramatically, hard drives still offer more storage for the same amount of money. For example, if you need several terabytes for backups, movies, or archives, HDDs remain a cost-effective option. That's why many users combine both technologies. They install the operating system and important applications on an SSD, then store large files on an HDD. This hybrid approach offers both speed and capacity. The technology continues to evolve. Modern SSDs are becoming faster every year. Manufacturers are pushing storage speeds that once seemed impossible. At the same time, software is increasingly designed to take advantage of these improvements. Games load larger environments. Applications process bigger datasets. Artificial intelligence workloads require faster access to information. Storage is no longer just about capacity. Speed is becoming equally important, and SSDs are leading that transformation. So why are SSDs faster than HDDs? The answer comes down to one key difference. Hard drives depend on moving mechanical parts. SSDs don't. By eliminating physical movement, SSDs can access data almost instantly. That single innovation has transformed how computers feel and perform. Whether you're gaming, editing videos, working, or simply browsing the web, an SSD can be one of the most noticeable upgrades you can make. And now, the next time your computer boots up in seconds, you'll know exactly why. If you enjoyed this breakdown, don't forget to like the video, subscribe for more technology explainers, and let us know in the comments. Are you still using an HDD, or have you already switched to an SSD?